Bandwidth management. How to do bandwidth management? The bandwidth management on the inbound and outbound traffic can be done via the following processes. 1. Setting the limit for incoming bandwidth and outgoing bandwidth for a specific Ethernet interface, E.geth0. 2. For the Ethernet interface defined in step 1, define the priority classes associated with that interface. It regulates the minimum rate, maximal allowed bandwidth, and the marks belonging to a specific priority classes. 3. Define the types of packets that shall be labeled, denoted as mark. The operation principles behind those definition processes are, for certain types of network packets, we tag them with special marks. The firewall will check the mark associated the packet to know the priority class it belongs to. And then, the packet is governed by the rule defined for that priority class for traffic prioritization. The following sections will explain those processes in detail. Limiting bandwidth for Ethernet interface. As a server deployed in the Internet, the bandwidth usage limit is usually governed by the link provided by the Internet service providers. For example, the XDSL provided by ISP might have the limit like 10 bit/s for download, 2 bit/s for upload. If the firewall is deployed behind that XDSL modem, the bandwidth usage will be governed by the link by nature. It does not make sense that the limit set in the firewall is not in the range provided by ISP. On border bandwidth interface limiting, there are 3 fields to fill in the user interface: Ethernet interface incoming bandwidth, kbit/sec, outgoing bandwidth, kbit/sec. For the limit of incoming bandwidth associated with the specified Ethernet interface, the system will actually drop the packets it receives to avoid that the incoming packets are over the limit. So, it actually regulates the packets it receives, it does not prevent the packets coming to the interface. Thus, if the system has the capacity or the processing power, it does not make sense to drop the packets. However, this feature can protect the system if the incoming packets are over the limit the system can handle. On the other hand, outgoing traffic above the limit of outgoing bandwidth associated with the specified Ethernet interface will be dropped. This is the total outgoing bandwidth associated with that Ethernet interface. If there is no other server sharing the internet bandwidth, it does not make sense to set the limit lower than the upload limit provided by the ISP. After pressing Add button, the setting will be shown in the right box. The system allows setting the limit for each Ethernet interface. Please note that, it is necessary to define priority classes associated with the Ethernet interfaces you already set the bandwidth limit. If none of the priority classes is defined, the firewall will not function at all. By the time you set the bandwidth limit of Ethernet interface, the system will generate 4 priority classes by default. You can modify them according to what you need. Traffic priority classes. How to create a class of prioritized traffic? We start with border bandwidth priority classes. As mentioned in the previous section, it is necessary to define priority classes associated with the Ethernet interface with limits set for outgoing and incoming bandwidth. The system will generate 4 priority classes automatically when the limits associated with an Ethernet interface are set. You can delete those classes you do not need. But for each Ethernet interface, it needs a default class and it has to be defined clearly. In the diagram above, it indicated priority class 3 is the default class if the network packets do not match the other rules. If the priority number is lower, it means it has higher priority. They are serviced in ascending order, 0, 1, 2, 3, 4, 5. The explanation of those fields in the screen is as follows: interface, the name of network interface, E.g, eth0, eth1. It does not allow aliasing here. Mark, the range is 1 to 55. In the other place, you can define which type of traffic shall be mark. Minimum rate, the minimum bandwidth this priority class should get. Max allowed bandwidth, the upper limit of the bandwidth for this class. The minimum rate and maximum allowed bandwidth can be specified explicitly like 100 kbit, 80 kbit, they stand for 100 kbit/sec and 80 kbit/sec respectively. Alternatively, it also can be specified as full, full/4, or full/8, it means the total bandwidth of the associated interface, 1/4 of the total bandwidth, and 1/8 of the total bandwidth. Priority, the values of the priority will be serviced in ascending order, E.g 1, 2, 3, 4, 5. Different classes can be set to equal priority value. It means the 2 classes of equal priority. Options, this field can be of the following possible values: default TOS equals 0x value /0x mask, mask defaults to 0x FF, TOS-TOS name TCP/AC. For details about TOS equals 0x value /0x mask and TOS-TOS name, it is necessary to check TOS/precedence/diff srv octet in the IP packet header. Previously, it was known as TOS byte. We just list them here without further explanation. the value/mask representation is equivalent to the following TOS name presentation: TOS minimize delay 0x10/0x10, TOS maximize throughput 0x08/0x08, TOS maximize reliability 0x04/0x04, TOS minimize cost 0x02/0x02, TOS normal service 0x00/0x1E4 TCP ACK. It means all the TCP ACK packets of that interface with length less than 64 bytes will go to this class. Traffic prioritizing with limits defined for interface and its associated priority classes. Previously, we can mark the packets here, border bandwidth traffic prioritizing. Thus, for each packet, once we know its mark, we will know its corresponding priority class so that it will be governed by the associated rules behind it. Mark, integer value in the range 1 to 55 packet source, the IP address or subnet of the source of the specified packet destination, the destination IP address or subnet that the packet will go to protocol, the protocol of the packet, TCP or UDP, destination port, the destination port number, TCP port or UDP port, of the packet.